Hello. So today we're going to do standard form, which is a very, very important concept. You'll find it in all papers, in all sections of work. They'll do a long calculation. They'll say, write your final answer in standard form or write your final answer in ordinary form. So it's very important to know what it is, how it works, and how to work from standard into ordinary form and from ordinary back into standard form. So let's start with just a few basic principles before we head into specific examples. So now the first thing to remember is this would be your standard form. Your standard form always has the decimal after the first digit in the number. So this standard form would be 1.23 times 10 to the index 11. 10 is the base, 11 is the index. Now this would indicate a very large number because it's a positive index. If I had 1.23 times 10 to the negative 7, as soon as you see a negative index, you know, okay, that's a small number. So that, once we've established that, now let's change this standard form to an ordinary form. So essentially that index of 11 tells us how many places or spaces we need to move the comma. And remember, it becomes bigger if it's positive. So if this is 1.23, we've got to move the comma, the decimal, 11 spaces. So let's see, 1.23, it would start there. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So essentially, I'm moving the decimal 11 spaces because the index is 11, but making it bigger. So after this, you would have comma 0.000, which essentially it plays no difference in changing the number. If it's 1.23 times 10 to the negative 7, negative implies that it's a very small number. So if that's 1.23, because it becomes a smaller number, we move it 7 places. 1, 2, 3, 4, 5, 6, 7. So the index always indicates how many places we move the comma to make it so much bigger or so much smaller. And so then that's basically how it works. It's really, really easy. It's just important that you know what these indicate. Are they small? Are they big numbers? What is ordinary? What is standard form? To change it from ordinary to standard form, if we look at this number here, 123, that's actually 123 billion. So if you imagine there was a comma there or decimal there, I'm going to use those two words interchangeably, comma, decimal, etc. If that was there in the normal case, that would be 123 billion.000. Picture that decimal there. Now, because standard form is always with the decimal after the first digit, the decimal would have to go there, 1.23. So to move it from there to there, it's moved how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in making this very large number more compact, I've moved the decimal 11 places. So that's why it's 10 to the 11. So the index indicates how many places or spaces you've moved the comma. Okay, now let's look at a few specific examples. Okay, so let's look at some examples now. We're going to convert these numbers from ordinary form to standard form. So if we look at the first one, that is the number 7 million. Now, if I want that into standard form, immediately we remember that the decimal goes after the first digit. So it's going to be 7.0 and it's going to be multiplied by 10. And we need to work out what the index is. So now the best way that I always find to do it is, what we do is we think, okay, this number is 7 million and I've changed it to 7. So I've changed 7 million to 7. So I've made it a lot smaller. So if I make it a lot smaller, the index must be positive. It must become bigger. So how many places have I moved the comma? Originally it would have been here. So that's going to be 1, 2, 3, 4, 5, 6. So that is going to be 7.0 times 10 to the 6. Let's look at another one. This here is 726.379. Now to standard form is going to be 7.26379 times 10, and I need to work out the index. So this is easy. You know, standard form is always comma after the first digit. So this is now 726 becomes 7.26. So I've made that number essentially smaller because 7 126 has become 7.26. So if I've made the number smaller, the index must become bigger or must be positive. So how many places have I moved it? 1, 2. So the index is going to be positive 2. Look at the third one. Now this number is 0.00071. So if I write it in standard form, my first digit is 7. So standard form is always the first, the comma after the first digit. So it's going to be 7.1 times 10. Now, this number has become bigger because 0.00071 is a small number and I've made it bigger by 7.1. So that immediately indicates that's going to be a negative index. How many places have I moved the comma or the decimal? I've moved it 1, 2, 3, 4. So this answer here is going to be -4. Whether it's positive or negative, you can find your own way to work it out. But for me, the way that I work it in my head and make sense is this is a small number become bigger. So if the smaller numbers become bigger, it's a negative indice. If the bigger number has become smaller, it's positive. That's one way of doing it. Okay, let's now look at the reverse. So now if I rub out this side, and the question is convert standard form to ordinary form. So now, if we've got 7.0 times 10 to the 6, you know that that means it's going to become a bigger number because it's a positive index. So this is going to be 7, and we're going to move the comma 6 places to make it bigger. So 1, 2, 3, 4, 5, 6. Let's check. Was there 1, 2, 3, 4, 5, 6? So your number has become 6 times 10, 6 times bigger. That's not really correct, but we've moved the comma 6 places. This one here, standard form to ordinary form, it's times 10 to the 2. So it's become bigger because that's positive. So if I moved it that way, it would become smaller. So it's become bigger by times 10 to the 2 by 100. So it can become 726.379. Let's just check. Times 10 to the 2, 726, comma, so yeah, that's right. Third one, because that's a negative index, -4, it means this number has to become smaller. So it's going to be 7, 1. Those zeros are not necessary because let's just rub this out, make it a bit neater. But what's happened is because this number's become smaller, the decimal needs to move this way by 4 places. So now I don't always know immediately how many zeros that is. So I put an extra just kind of padding and now I move it. So to 10 to the -4, it's initially here. So it's going to be 1, 2, 3, 4. So it's actually going to be there. So I don't need this 0 here. So I get rid of that. And I just neaten that up a little bit. Let's double check. 7.1 times 10 to the -4 becomes smaller. Move it 4 places. Was originally here. 1, 2, 3, 4. Perfect. So what's happened here is this number has become smaller. This number has become bigger. This number has become bigger. And in your head, it's always useful to work out with the indices, which is the index. Has it become bigger, smaller? Do I move it to the right, to the left? Does it make sense? Now we're going to move on to using these numbers for the 4 operations: addition, subtraction, multiplication, and division. Let's move on to that. Bye for now. Okay, let's look at some examples on multiplication and division using standard form. Now, multiplication and division is really easy because we've got rules that we can use when we work with indices. So if we do some 3 examples quickly here, if we have 2.1 times 10 to the 5 times 3.6 times 10 to the 8. Both of these numbers are in standard form. So what we can do is we know that there's a rule for this here. When we have the same base, which is 10 and 10, we just add the indices. Remember that. So all we need to do is we need to multiply 2.1 by 3.6. If it's a non-calculator paper, you've got to remember your rules. So you multiply here and you get 7.56. So this answer here is 7.56. That's the result of 2.1 times 3.6. Then we have to multiply these two together. And we know that the rule is you keep the base of 10 and you add the indices. 5 plus 8 is 13. And you must always double check on your calculator to see that what I'm teaching you is true. Okay, very important. Let's look at number 2. It's multiplication. So we know that I can just, to multiply the same basis, I just add the indices. So we just need to work out 2.1 times 3.6. We've already worked that out. It's 7.56 times 10, add the indices, 5 add minus 8 is minus 3. So now therefore these are both in standard form, no problem. Let's do the last one, number 3. So now 9.126 times 8.9. If you needed to do without a calculator, hopefully you remember how to do that. But let's say this was on a calculator paper. So the first thing we do is we've got to go 9.126 multiplied by 8.9, and we get the answer of 81.2214. Don't forget, we've still got to add our indices, which is going to be minus 8 add 10. Minus 8 add 10 is 10 squared. But this final answer is not yet in standard form. And let's say each of these answers needed to be in standard form. So now we've got to change this a little bit. So now remember, our standard form is always decimal after the first digit. So this has to become 8.12214. This is not standard form because it's 81. It has to be 8.1. And we still need to finish it off times 10. Now, does that become 10 to the 1, 10 to the 3? The best way to remember is what I was talking about earlier. That's 81. So that becomes 8.1. In a way, that becomes smaller. So I've moved the decimal from 81 to become 8.1. It's become smaller, so the index must become bigger. Now, those two are equal to each other. This would be standard form. Okay, I hope that helps. Now let's do a few on division. Now let's do an example with division. Division also nice and manageable, because if we have standard form divided by standard form, what we can do is we can separate, and we can first do 1.2 divided by 4, and then we can deal with the indices, with the tens, because we know that there's a rule. So let's start off with 1.2 divided by 4. Need to remember your division of decimals. Remember, maths is building all the time. So you hopefully remember how to do it. We have different styles, different ways, but hopefully you get the answer of 0.3. So 0.3 times 10. Now let's remember our rules here. So if we have 10.7 divided by 10 to the negative 3, the rule is I subtract the indices. So essentially I'm going 7, take away negative 3. And remember, when you subtract a negative, it becomes add. So that's actually going to produce 10 to the power 10. This is not in standard form. So we need to change that into standard form. So standard form would be 3.0, because your first digit in this number is 3. And after that is just 0. So 3.0 times 10. Now once again, the question, does that go up? We've only moved the decimal one place. Does it go up to 11 or down to 9? Remember, this has got bigger. So if that's got bigger, this must get smaller. So 10 goes down to 9. Why down to 9? Because I've only moved the decimal one place. So because I've moved that one place and it's got bigger, that must get smaller. And if you just translate this to more difficult ones, just remember it's the same thing. You do the division separately of the numbers, and then you deal with the powers. If you can use a calculator, absolutely use a calculator. If you can't, we need to remember the rules of how to do long division with decimals. And then don't forget, your final answer 90% of the time needs to always be in standard form. And standard form is the first digit, point, whatever the numbers afterwards, and times 10 with an index. Cool. Let's move on to the next one, addition and subtraction. Okay, let's now end off with an example on addition and subtraction of standard form. So in the first example, I've got 2.7 times 10 to the 3 add 7.25 times 10 to the 4. Now, we can't add these just straight off, because that 10 to the power 3 and 10 to the power 4 have different indices. So we can't use any rules, because we don't have any rules where we can add when we can add powers that have different indices. So the best way to do this is to change each of these standard forms into ordinary form. So we go back to our original knowledge, and this becomes bigger because it's 10 to the power 3. So this will be 2, 7, 0, 0. I'm not sure if there's another one or not, so let's check. The decimal is there, and I've moved it 3 places, 1, 2, 3. So that's right. And then I need to also change the second number to an ordinary number, not standard form. So this is going to be 725. And because it's times 10 to the power 4, I would move the decimal 4 places to make it bigger. 1, 2, 3, 4. So it looks like I'm going to have another 2 zeros. Let's just check. It was originally there. 1, 2, 3, 4. Correct. Now I'm going to add these two numbers together. So once again, you need to remember your building blocks. We add these two numbers together, and we get an answer of 75,200. And that's my answer. But so often they want it back into standard form. So we change it from ordinary back into standard form. And remember, standard form always has our decimal after the first digit, 7.52. Now we need to work out the new index. So that has changed from a very big number to a small number. So this must become big. How many places have I moved the decimal? It would be there, 0.000. We've moved it 1, 2, 3, 4. So that would be my answer, 7.52 times 10 to the 4. Let's look at subtraction. And subtraction we need to do in exactly the same way. If it's a calculator paper, no problem. But if it's not, we need to first change to an ordinary number. So this to an ordinary number, be careful, that's a -3, so it becomes smaller. So this number is still 36, but I have to put a few zeros in front. I don't know how many, so I always put an extra few and then I count. So the decimal is originally there, and I've made it 3 times smaller because it's to the -3. So it's going to go 1, 2, 3. Guessed correctly. So that's in standard form, that's in ordinary form, same number. Subtract 2.1 times 10 to the -5. Okay, so it's going to become smaller. So how much smaller, I'm not sure, so I'm going to put a few extra zeros. Let's see, so it's 2.1, so initially my decimal is there, we're going to move it 5 places. 1, 2, 3, 4, 5. Guessing well today, aren't I? Okay, now we do your subtraction. So we're going to, I've just done it here, hopefully you remember how to do it. Subtract, and I get an answer of 0.003579. That's my answer, but it's not in standard form. Let's convert it to standard form. So remember, standard form is always your decimal after the first digit. So it's going to be 3.579 times 10 to the power of something. We need to work out what that index is. So now let's see. This is a small number, and I've made it bigger. So if I make a small number bigger, this needs to become smaller. So this is going to be negative. How many places have I moved it? It was here, 1, 2, 3. So that's going to be to the -3. So I've made a small number bigger, so it has to be to the minus, must become smaller. Okay, there we go. And then once again, you just take these type of examples and you just remember the rules and you put them into any type of examples. Often they are asked in terms of problem solving story sums, when they'll say the speed of light is this, or the size of a tiny molecule is this, what would the size be, or the volume or the capacity of 20 of them, and you've got to use your multiplication. So there'll be story sums, and in the story sums you must choose, am I going to add, subtract, multiply, or divide? And that's where all these rules come into play. Easy peasy. Good luck. See you again.